This video is to help you to know how to solve multi-step equations, linear equations, and it assumes that you've already reviewed or refreshed yourself on solving multi-step equations using, and there is a video on this already, so if you haven't seen that, you want to do that. It kind of assumes that you've already done that and are ready for a longer equation. Okay, so for this particular set of problems, we're going to use these 3 steps. So step 1, you're going to simplify if needed on each side of the equation. So that's this step right here. We're going to simplify if needed on each side of the equation. So we're going to do that first for this equation where we're solving for x. All right, so for this step, I can combine on the side of the 12 minus 8. You don't have to do this first, but it will make things easier sometimes. So I'm going to do that in this case. And on the other side, there's only nothing to do, so I'm just going to copy that. So I'm just adding and subtracting like terms, and there was only 12 and minus 8 to do. So I'm done with step 1. Step 2, if there are variables on both sides of the equation, and in this case there are, because there's 5x and 12x on both sides, then get rid of the variables on one side by adding / subtracting. So let me explain to you what that means in this problem. So we can't solve for x if it's on both sides of the equations. That's the problem. So we have to get rid of one of them. And it doesn't matter which one, except that sometimes it'll make it easier if you do it one way rather than another. In this case, I'm just going to subtract. I'm going to get rid of this one, but again, it doesn't matter which side you chose. And I'm going to get rid of the plus 12x. So you get rid of whichever one you get rid of, you have to get rid of it by doing the opposite operation. So because this is plus 12x, I'm going to subtract. And if it were negative 12x, I would add, okay? So it's always the opposite of what it is. So again, I'm going to subtract 12x. In order to keep this equation equal and balanced, I have to do the same thing on both sides. So if I subtract 12x from this side, I have to subtract 12x from this side. 5x minus 12x is negative 7x. Step 3, isolate the variable by using inverse operations. So basically, this is, once I've done step 1 and step 2, I have made this a normal equation. Because the big thing that was making this a little bit harder was because there were so many terms and there was variables on both sides. So I've gotten rid of that problem. So now I'm just going to solve it like a normal equation. This is where you have to isolate. So I don't want negative 7x plus 4 equals. I want x equals. So I have to get rid of the plus 4 and I have to get rid of the negative 7. So I can get just x equals instead of all that mishmash. I have to use inverse operations, but I also have to use the SADMEP order. So remember that when solving, you do it in reverse PEMDAS order, okay? And the previous video talks about why. And so I have to get rid of anything that's subtracted or added to x first. So this plus 4 is the first thing that has to go by that order. So I'm going to get rid of the plus 4 by doing the inverse operation, or the opposite of plus 4 is minus 4, and I have to do it to both sides. So I have now gotten rid of that. The subtraction addition in the problem needs to be gotten rid of first. So this cancels out, and this becomes a negative 14. The next thing I have to get rid of is anything that's multiplied or divided to the variable. So this is negative 7 times x, so I have to get rid of times negative 7 by doing the opposite operation with the same number, which is divided by negative 7. And that's going to become x equals 2. That's it. I solved now. There's nothing else to do, so I don't have to check for the other 2. Let's do another example. I'm going to have to erase this so I can use the same space. So a slightly different problem. So example 2. Let's do 2 times 3x minus 4 equals 3x plus 2. I would pause the video and see if you could do this on your own as much as you can before watching and getting some help as needed. Okay. And you can do that, of course, at any point in the video. I always encourage you to do as much as you can by yourself. It's going to help you to do better later. All right, step 1, simplify if needed. So in this case, I want to distribute the 2 to everything in the parentheses on the left-hand side, so that's what I can simplify. 2 times 3 is 6x, 2 times negative 4 is negative 8. And on the right-hand side, there's nothing to do, so I'm just going to copy that again. So that's step 1. Step 2, if there are variables on both sides of the equation, and I look here, and are there variables on both sides? Take a look and see if you can see. If there are, then get rid of the variables on one side by adding or subtracting. So if you said yes, there are variables on both sides because there's a 3x and a 6x, you are correct. So you're going to pick one of them to get rid of. I'm going to choose the plus 3x. So think about how you would get rid of that. Because if it's a plus 3x, you do the opposite, so you should subtract 3x. From both sides, you have to do the same thing on both sides of an equation. So 6x minus 3x is 3x. And I now have an equation with variables only on one side, which was my goal for step 2. Step 3, isolate the variable by using inverse operations. So you have to do opposite operations. Remember, we have to use SADMEP order, the opposite of PEMDAS. Okay. So I need to get x equals, not 3x minus 8 equals. So I need to solve for x. I need to isolate the x by getting rid of the minus 8 and the 3. Which one do I have to get rid of first using SADMEP? Which one do I have to get rid of first? If you said that you have to get rid of the minus 8 first, you'd be correct, because by SADMEP, you have to get rid of anything that's added or subtracted first. So I'm going to get rid of the minus 8 by doing what? Hopefully you said plus 8. That would be the opposite of minus 8. So that would be 3x equals 9. Next, you have to get rid of anything that's multiplied or divided to the x, so that's 3 times x. So the opposite of times 3 is divided by 3. So that's going to cancel that out, and that's going to become x equals 3. Let's do another example. Also different, slightly different. So for this one, step 1 is to simplify if needed. So in this case, the thing that's making it look hard is that it's a fraction. And even worse, it has a variable in the denominator. So you have to simplify this. The other ones, you might have had a little bit of choice, but here's it. You have to get rid of that x minus 3 to solve this. So in order to do that, you're going to just multiply by the common denominator. There's only one denominator, it's x minus 3. So that's what you're going to multiply everything by. So you're going to, anytime there's a fraction and you want to simplify it, you just multiply by the common denominator. In this case, just x minus 3. Okay. What's going to happen is x minus 3 is the same thing as x minus 3 over 1. So I can just put it over 1 just to make it clear that that's why we can cancel that, because x minus 3 cancels one number. So that cancels on the top and the bottom there. So what's left on the left is just x plus 2, which is nice. It's not a fraction anymore. And then on the right-hand side, I can simplify that by distributing the 2. So that's 2x minus 6. Step 2. If there are variables on both sides of the equation, then get rid of the variables on one side by adding or subtracting. So you're going to check, are there variables on both sides? And then you'll have to do step 2. Indeed, there are variables on both sides. And just for the sake of showing you that you can do it on either side, I could get rid of the 2x if I want, or the x. I just have to choose one side that I have to get rid of the variables from. So I'll just do it from this side just so you can see that you can do that, okay? So I'm going to get rid of that x. I'm going to subtract x from both sides. That cancels out. 2x minus 1x equals 1x minus 6. I now have an equation with a variable only on one side, which is what I need. Okay, I can't solve it if there's variables on both sides. Step 3, I'm now going to isolate the variable. And so I'm going to do that by adding 6 to both sides. X equals 8. And it's much more normal to write it with the x on the left side, so that's the way I'm going to write it. You would have to double check that x equals 8 works here because there's a variable in the denominator. So you need to just make sure that it doesn't cause there to be a problem. Like if the number that I got made the denominator equal to 0, then it would be something called an excluded value or an extraneous solution because it's a solution that doesn't work. But in this case, the x equals 8 does work, so it's not a problem. So that's something to take a look at. All right, last example that we will do together. And this one's not hard, just wanted to do one more with a fraction in it. So again, this is a good time for you to pause the video and see if you can figure out how to do this one on your own. The first step is to simplify if needed. And you do have a denominator, but it doesn't have a variable. So I don't have to do this, but I'm going to just because it's going to make my life easier. So anytime there's a fraction, you can always get rid of it by finding the common denominator. So here, again, there's only one denominator. So that common denominator is 2. And then I can multiply. Anytime there's a fraction, I can multiply the whole equation by the LCD to get rid of the fraction. And that's going to get rid of all the fractions, to get rid of all fractions. So let's do an example here. The LCD is 2, so I'm going to multiply the first one, 5x over 2. Let me just rewrite this equation. And I'm going to multiply each term by 2. So the idea is I'm multiplying the entire equation by 2, right? So I'm being fair. I'm keeping the equation equal because I'm doing it on the left side and on the right side, times 2 and times 2. So I am just going to distribute this. So 2 times 5x minus 2. So I'm writing that down here. Remember, 2 is the same thing as 2 over 1. And I'm going to distribute that to the 3x over here. And then I'm going to distribute it to the 5. So here on the fraction side, I can cancel that out. So that's just going to be 5x. On this side, 3x times 2 is 6x. And 5 times 2 is 10. Okay. Now we're on step 2. Before I do that, let me just go over this one more time because I feel like if you're going to get confused anywhere, it's going to be in this step. So again, we found the LCD of 2. I took the equation, which was, I'm just rewriting the equation. And I'm multiplying this entire equation by 2. And that's okay because I'm doubling the left side. I'm making this side bigger by 2 times, and I'm also making this side bigger by 2 times. So it's still going to be equal because both sides are bigger by 2 times. So whatever the numbers are, they've increased by the same amount. And I'm going to show that that 2 is distributed by just saying this one times 2. Oh, let me just write it the same way as before, just so it doesn't look confusing. This one by 2, this one by 2, and this one by 2. Multiplying by 2 is the same thing as 2 over 1, the same number. And I just kind of put it over 1 so that it's easier for me to multiply by a fraction. I cross cancel those 2's, and I get 5x equals 6x, equals 3x times 2 is 6x, plus 5 times 2 is 10. All right, step 2, see if you can do this on your own. Remember again, if there is a variable on both sides, and there is here, you need to get rid of one of them. So it doesn't matter which side, I'm just going to do it on this side. So I'm going to subtract 6, that's positive 6x. This cancels out, I get negative x equals 10. And now I solve by isolating x. Negative x is not x, guys. It is not good enough to just leave it as negative x equals 10. You want positive x. So you have to remember that a negative x is really, there's an invisible 1, so it's really negative 1 times x equals 10. You have to know that. They're not going to tell you that. And that way you know to get rid of a times negative 1, you have to divide by negative 1 on both sides, so you get x equals negative 10. And that will be your answer. And that should be enough for you to do these problems on your own. And a worksheet or practice problems.